In this section we do the derivatives of inverse trig functions. For us to be able to do this quickly and efficiently, there are two tables that you have to memorize. There's no way around it. You have to memorize these two tables. The first one is the derivative of regular trig functions. The derivative, for example, of sine. The derivative of sine of x is cosine x. You just have to memorize it. The derivative of cosine x is negative sine of x. And the derivative of tangent of x is equal to secant squared x. That you have to memorize. Three more you have to memorize. The derivative of cosecant x is equal to negative cosecant x cotangent x. The derivative of secant x is equal to secant x tangent x. Lastly, the derivative of cotangent x is equal to negative cosecant squared x. You got to check this for me because I think that's right, but I don't think I wrote it down right. These are regular trig functions: sine, cosine, tangent, cosecant, secant, cotangent. These are the derivatives for those trig functions. Now, an inverse trig function, for example, an inverse trig function would look something like this. Let's say radical 2 over 2. What this function is asking is, what angle has a sine of radical 2 over 2? In this case, radical 2 over 2, the sine of 45, which is pi over 4, in radian measure, also known as 45 degrees, that has a sine of radical 2 over 2. So the answer for this one would be pi over 4, or you can write 45 degrees. Most likely they're going to ask you for radian measure. This is 180 divided by 4. That comes out to 45. There's a chart that you have to memorize, and not just for, let's do the derivative of these. The derivative of the inverse sine of x is 1 over 1 minus x squared. That's just an example of what an inverse trigonometric function looks like. This is the derivative of sine. The inverse of sine is 1 over 1 minus x squared. That's the derivative. dx. The derivative of dx. Derivative of that times the derivative of dx. D over dx of the inverse of cosine of s, the derivative of that is negative 1 over radical 1 over x to the second dx. And the derivative of tangent, the inverse tangent, tangent of 1 of x is equal to 1 over 1 plus x squared. Those are sine, cosine, tangent. The derivative of the inverse sine, inverse cosine, inverse tangent. Now we have to find the derivative. I'm not going to show you how to get it. This is, again, something you have to memorize. The derivative of inverse cosecant of x. That's equal to negative 1 over the absolute value of x times the radical of x squared minus 1. You have to memorize it. There's no way around it. D over dx of secant negative 1 of x is equal to something very similar, except it's positive. This is x squared minus 1 inside the radical times the absolute value of x. Notice that this is negative. The derivative of the inverse cosecant is negative. The derivative of inverse secant is positive, but it's the same derivative. Remember that cosecant is 1 over sine. Secant is 1 over cosine. Some students get confused because it starts with a C. Cosecant actually goes with sine. Secant actually goes with cosine. And the last one, the derivative of the inverse of cotangent, negative 1 of x, that equals negative 1 over 1 plus x squared. That's the second chart that you have to memorize. This is dx, dx, dx. Because once you take the derivative, you get this, but then you take the derivative of whatever's on the inside. And oftentimes, because it's a chain rule applies, you have to take the derivative, then take the derivative on the inside and multiply it. So we put a dx. The last chart you have to memorize is something from way back in high school, maybe even 9th grade, is the sine, cosine, and tangent of different angles. We have the sine, we have the cosine, and we have the tangent. What angles are we talking about? Well, we're talking about 0. We're talking about pi over 6, which is 30 degrees. We're talking about pi over 4, which is 45 degrees. Pi over 3, which is 60 degrees. And we're talking about pi over 2, which is 180. I'm sorry, 90 degrees. Pi over 2, which is 90. Let me switch this around just a little bit and fill in the values. We have the sine, we have the cosine, and we have the tangent. The sine for 0. The sine of 0, 0, 1, 0. The sine for pi over 6, finish filling out the chart. This also you have to have memorized. There's no way around it. The sine of 30 degrees, or pi over 6, sine, cosine, tangent, is 1/2 for the sine, radical 3 over 2, and radical 3 over 3. That's for pi over 6 or 30 degrees. Now pi over 4. This one's a little bit easier to memorize. Radical 2 over 2 for sine, radical 2 over 2 for cosine, and tangent is actually 1. For 60 degrees, radical 3 over 2. For cosine, 1/2. And for tangent, we have radical 3. For sine of 90 is 1. Cosine of 90 is 0. And our tangent is undefined. We don't have a tangent for 0. For 90 degrees. Contains no tangent. This chart has to be memorized. Sine, cosine, tangent. An easy way to memorize it, I found, is take the 30 and the 60. Notice that the sine goes with the half here. This has a half here. The sine for the 60, the radical 3 over 2 is for the sine up here. Radical 3 over 2 is the sine down here. Here, the tangent for 30, radical 3 over 3, tangent for 60, radical 3 by itself. And then 90 is 1, 0, undefined. Now let's do some problems with those charts. The first 4 problems are relatively straightforward. Number 1 says, okay, the sine, inverse sine of 1/2. What it's asking is, what angle has a sine of 1/2? Well, looking at our chart, we see that it's pi over 6. Booyah. Done. Question number 2. They say cosine of -1. 1 over radical 2. Now, in the chart, we don't have a 1 over radical 2. What they do is they try to trick you. 1 over radical 2, they don't like in general to have radicals on the bottom. So what we do to get rid of the radical on the bottom, we multiply that by a 1. Radical 2 over radical 2 is actually a 1. So we're allowed to do that to that one number. If we do that, notice what happens to the radicals on the bottom. They cancel out, and we multiply the radical on the top. So this actually becomes cosine, inverse cosine of radical 2 over 2. Now, what angle has a cosine of radical 2 over 2? Well, that's pi over 4. Number 3, we have the cosine of the inverse sine of radical 2 over 2. Notice what it's asking. It's asking what angle, first of all, inside the parentheses, what angle has a sine of radical 2 over 2? Well, we know that that's pi over 4 based on our chart. So the cosine of pi over 4, or 45 degrees. Now, looking at our chart again, the cosine of 45 degrees is radical 2 over 2. That's our answer for number 3. For number 4, we have tangent on the outside. Inside the parentheses, I have down cosine -1, inverse cosine, radical 2 over 2. Close parentheses is equal to. Well, we first do the inside parentheses. The inverse cosine of radical 2 over 2. What angle has a cosine of radical 2 over 2? Well, that has to be pi over 4. So the tangent of pi over 4, 45 degrees. What is the tangent of 45 degrees? According to our chart, 1. So those are our answers, 1 through 4. Very straightforward. Now, unfortunately, it gets a little bit more complicated. So far, we haven't done derivatives of inverse. Now we begin derivatives of inverse. Let's do number 5. Number 5 says the following. Find the derivative, dy dx, of cosine, inverse cosine of 5x to the 7th. Well, that's inside the parentheses. We're going to eventually have to find what the derivative of 5x to the 7th is. I'm going to label it u. And so our u is 5x over 7. That means our du, our derivative for that, is, I'm going to bring the 7 down, times 5 is 35 x to the 6. I did that so I can just plug it in at the end. So the derivative of this becomes, the derivative of this, of cosine -1 of u. Looking at our chart, we know that the derivative of the inverse cosine is 1 over whatever the x is. Inside radical 1 minus whatever the x is, 5x to the 7th to the 2nd power. I plug in what that u is. That's the u that I plugged in. U's up here, 5x to the 7th. Times du. Du is 35 x to the 6th. Multiplying across, I get, let me see, multiplying across, I get negative, don't forget the negative in front, negative 35 x to the 6th on the top. On the bottom, I have 1 minus 5 to the x to the 7th to the 2nd power. This becomes 25. X to the 7th to the 2nd power becomes x to the 14. Inside the radical. And that is dy dx. That's number 6. 6, they want, this is our function, sine of -1, and our inside the parentheses we have a radical. I wrote this down, I probably wrote down right, but I'm not sure. It looks like it's pi, the square root of pi times t. That's what it looks like to me. We first take the derivative of the outside, which becomes, if we do that, we take the derivative with respect to t, this becomes 1 over square root of 1 minus, and then whatever the x value is, which is radical of pi times t, we square that, and then we take the derivative of the inside. Radical pi times t, the derivative of that is just the radical pi. That's what that becomes. So we keep that on the top and bring it down here. This becomes radical pi on the top, and that's over square root of 1 minus, is there a minus in the front anywhere? No. Sine, see, what was the chart? Sine, there's no negative, okay. 1 minus square root of pi radical t, that to the 2nd power. Simplifying that, we can simplify the bottom. If we take squared of the square root of pi, and we take the squared to the t, the bottom becomes, the top stays the same, radical of pi over the square root of 1 minus pi, because radical of pi times radical of pi gets rid of the radical, so we're left with just pi, and this becomes t squared inside the square root. And that is our final answer for number 6. Number 7. Number 7. Y is equal to cosecant -1, 3x squared plus 1. The derivative of cosecant, with respect to x, dy dx, is negative. So 1 over the absolute value of x, which is 3x squared plus 1, times the square root, still on the bottom, times the square root of x squared, which is 3x squared plus 1, that's squared minus 1. That's inside the parentheses, is 1 up here. Now we're going to try to simplify this on the bottom inside the square root. Inside the square root here, this is 3x squared plus 1 times 3x squared plus 1. So on the bottom, we're going to leave the top the same. Bottom, the absolute value, I'm going to leave the same. Now I'm going to take this a little bit and break it down into its parts. Plus 1. 3x squared plus 1 minus 1 inside the square root. Now for even more fun, I distribute this on the inside, do the distributive property for that. Inside just the square root. After simplifying, I get 9x to the 4th plus 6x squared plus 1 minus 1 cancel out, so I'm left with just that on the bottom. That's going to be times 3x squared plus 1 on the top minus over here. Now, if you didn't follow exactly how I simplified from here to here, due to distributive property, you'll get these numbers and you'll get a 1 on the outside, and 1 minus 1 is out to 0. I just simplified quick, but you would have to go through and simplify it yourself. If you have questions, just let me know. Simplifying the bottom, I'm going to try to see if I can simplify it. On the inside, I always try to pull stuff out to see if the absolute value I can't do anything with. Maybe that's exactly the same, although it looks like I could maybe, but that's too painful. On the bottom, from the 9x to the fourth and the 6x to the second, I can pull out a 3x squared from both of those. I'm left with 3x squared plus 2. I'll pull that out. Now this is this times this. So because it's inside the square root and it's I can consider it multiplication, this x squared I can pull 1x out. I can pull one of those x's out. I can't pull the 3 out because there's nothing divisible by 3. But I can take the x out, and I'm going to bring that to the front. So this becomes negative 1 over x, absolute value, 3x squared plus 1, close value. Inside the parentheses, I'm left with 3 times, I'll multiply that back in. The little 3 didn't help me for anything, so I'll plug it back in, multiply it back in. I'm left with, on the bottom, 9x squared plus 6. And that's my final answer. Great. Phi equals u square root of 1 minus u squared minus sine negative 1 of u. And they ask you to find dy du. Notice this is a combination problem. This part is inverse trigonometric. This part is just a regular standard derivative. So dy, this is a product rule. First times the derivative of the second. The derivative of this is 1/2 1 minus u to the second minus 1/2, because I take 1 away from there, and then I take the derivative of the inside. The derivative of the inside is bring down the 2, so it's a minus 2u on the inside. That's the first part. First times the derivative of the second, plus the second, which is radical 1 minus u to the second, times the derivative of the first. The derivative of du is just 1, so that stays the same. Now we take the derivative of sine of negative 1. The derivative of inverse sine is 1 over radical 1 minus u squared. That's the derivative of that. It looks like we may be able to simplify a few things. If we simplify here, because we're just multiplying across, this u and this u come out to u squared. The negative 2 I can multiply in the beginning, so it's going to be a minus 2 u to the second plus 2 . plus square root of 1 minus u squared minus 1 over radical 1 minus u squared. These two cancel out, and I'm left with that. You could leave it like that. That is a derivative. There might be a way to simplify it. It'd be nice if we can add all these together. That would be u squared plus equal 1 minus u squared minus 1 over 1 minus u squared. But the only way to add all these three together would be to find a common denominator. This doesn't have a denominator. That's a 1. That's a 1. That one has a denominator. What I could do is multiply this denominator times here and here on the top and the bottom. Let me show you what I mean. This would become u minus 1 minus u squared plus square root of minus u squared times 1 minus u squared minus 1 all over. It's an old trick. It does work to simplify. Notice what happens. Now they all have the common denominator, because if you simplify this, it would go back into this. But same, but just a different form. And notice what happens on the top. This and this cancel out. So that's kind of cool. So we can do here, we're left with u squared 1 minus u squared plus this and this, we're left with just 1 1 minus u squared minus 1. Notice what happens to the 1 and the negative 1 out here. Boom, boom. So I'm left with radical 1 over, minus u squared minus u squared all over radical 1 minus u squared. As far as I would take it. You could factor out a u squared, and you'd be left with u squared parenthesis 1 minus 1 all over all over 1 minus u squared. Either I would that's go. And that's all she wrote for that problem. Let's do number 9. 9's kind of a doozy. 9 is equal to y is equal to minus 1 radical 9x squared minus 1 cosecant minus 1 3x. They give you a stipulation x has to be greater than 1/3. The reason that's true, x has to be greater than 1/3, is if you plug it in, if you plug in a 1/3, notice it doesn't say equal to, if you plug in a 1/3 or anything less than 1/3, some of these things become undefined. And you can't have that. You can't have, for example, if you plug in a 1/3, yeah, it becomes undefined. This becomes a 0, and squared, it's all messed up. So that's why you have to put that stipulation. So let's take the derivative. Dy dx. The derivative of tangent is 1 over 1 plus, looking at our chart, 9x squared minus 1. That's what's inside as x. That's our x value squared. And then we give times the derivative of the inside. The derivative of the inside would bring the 2 times the 9. It gives me 18x. Plus, now we do the second part, cosecant. Cosecant is a minus 1 over absolute of the radical. That's our x value. 9x squared minus 1. Minus 1. Inside the radical, there's the absolute value times the radical of 9x squared minus 1, that squared minus 1, all in the radical. That's the derivative all plugged in. So simplified, this would be 18x over 1 plus 9x squared minus 1 squared all over absolute value, square roots. Notice in mathematics we have to repeat ourselves a lot. We have to be careful as we rewrite the problems again and again and again and again. That's why it's so tedious. Absolute value, inside the absolute value, 9x squared minus 1, that's squared minus 1. That is the derivative. Of course, in mathematics, you would think, oh, it's over. We're fine. We don't need to do anything else. Absolutely nothing else. Of course we do. If we simplify this part here, what this means is 9x squared minus 1 times 9x squared minus 1. I'm going to show you a freehand version. Basically, I'm not going to do it in my head. I just don't want to go through the whole process. This comes out to 9 times 9. Can I do this right? Let's see. Now let's do it anyways. I'm going to fix this here. This is 9x squared minus 1 times squared minus 1. And then minus 1 out here. This becomes 81. Put one on my notes. 81x squared minus 9 minus 9x squared plus 1. That's a minus 1 out here. So this and this cancel out. Right over here, minus 1. Absolute value. So 9x squared. Absolute value times those cancel out. It's because 81 to the fourth. 81 fourth 18 x to the second inside the 81. If I factor out, what can I factor out? Does 81, let me check real quick, does 81 divided by 18? I think so. 4.5, no. That's odd. Should be 18. Okay, I'm going to pull out a 9. I'll pull out a 9 out of the 81, and I'm going to pull a 9 out of here. I pull out a 9 inside this would be times 9 next to the, I'll pull out our next second also. Here. So, if I pull out a 9 to the second, inside here I'm left with 9 next to the second minus 9. instead of there. I can actually pull out another 3. I can actually pull out a 27. 27 what? 20, 81 divided by 27. Yes! So I can pull out actually a 27. Sorry about that. If I pull out a 27, inside the parentheses I am left with 3 to the second. No, I can't pull out a 27. No, I can only pull out a 9. Here we go. Pull out inside the radical. I pull out a 9, x to the second. I'm left with 9 x to the second minus 2. 2. That's it, 2. This I can pull out. This becomes a 3x in the front. The 3x in the front goes to the very front. So on the bottom, it comes out to 3x absolute value next to minus 1 absolute value. And all of that over. Yes. So that, sorry for the chicken scratch. Okay, let's do number 10. Number 10. Oh Lord, y is equal to 9x to the 4th minus 1, 9x plus square root of 1 minus 1 next to the 8th. That's what I've written down. That's what it looks like. This is a product rule. First times the derivative of the second, we're looking for dy dx. So it's times the derivative of the second. The derivative of sine of inverse sine is 1 over square root of 1 minus whatever the x is. In this case, is 9x to the 4th, the second part there. And then the derivative of the inside. The derivative of the inside is 36x to the 3rd. That's the derivative of the inside. We multiply that. So it's first times the derivative of the second plus second, which is sine negative 1 next to the 4th times the derivative of the first. Derivative of the 4th we found will be 36x to the 3rd. X to the 3rd. That's just for this one. Now we're going to do the derivative of the second part right here. Plus 1/2, because the square root is 1/2. 1 minus 8, x to the 8th. Take away 1 from 1/2, we get a negative 1/2. And we take the derivative of the inside. The derivative of the inside will bring the 8 times 81. So it's 81 times 8. 648 minus 648 x to the 7th. That's just that derivative. Now let's see if we can simplify anything across here in this first part. If we multiply across, this becomes 36 times 9 gives us 324. That's that and that. X to the 4th times x to the 3rd gives you x to the 7th. And that is over radical 1 minus by this. This is 9 times 9 is 81. This becomes x to the 8th. That's that there. Plus, we can't do anything with that. I'm going to put the 36x cubed times sine negative 1 of 9x to the 4th. And then I'm going to try to simplify this. Plus, I'm sorry, minus, because the minus is there. And minus gets multiplied all the way across. So that becomes a minus on the top 648 x to the 7th up to radical 1 minus 81 x to the 8th. That's that part. 648 divided by 2, we can simplify a little bit more. If we wanted to simplify that, we could. If I did this right. Yeah, this 648 could be simplified. 324. So this could give us, this is 324. But notice what happens to the 324x to this over radical over minus 81x to the 8th. Minus 324x to the 7th over 1 minus x to the 8th. What happens is this is out and this is out. Isn't that a hoot? So we're left with 36 cubed sine minus 1, 9 to the 4th. That, my friends, is the final math. I'm terrible at math. Let's try number 11. 11? Yes, 11. 11 says, are these functions defined? If they are, what's the answer? Well, the way to find out, let's look at the first one, A. If what they're asking for is in the domain. Remember that secant of x is 1 over cosine. In the domain for the cosine is negative 1. Domain is what x's we can plug in. Has to be between negative 1 and 1. That's for cosine of x. That's the domain. That's the numbers we're allowed to plug in for our x values. Numbers have to be a fraction that is between negative 1 and positive 1. Remember the unit circle. For secant, because it's pretty much the inverse, the domain is a little different. The domain for secant is equal to negative 1. It has to be less than or equal to negative 1, or x has to be greater than or equal to positive 1. Now looking at, it has to be less than, in other words, it has to be 1.5, 1.4, 1.7, anything less than. Remember the less than is in that direction, and greater than is in that direction. X has to be in 1, so it can be 1.2, 1.3, 1.7. Secant, they gave us a value of negative 3/4. That is negative 0.6. That is not in the domain of, so it's undefined, and there is no value for any angle defined in that because it is the domain. It's not within the domain of secant. B, something very similar. B, they give you sine, inverse sine 3. Now, is there any angle, the domain, for sine is also, x has to be between -1 and the range also has to be greater. But for the inverse of sine, not for the inverse, radical 3, that's greater than 1. It's 1 point something. So that is not in the domain, so it's undefined. Doesn't have a value. So both of these are undefined. And that was that section. Hope it helps.